Hi everyone, and welcome to the episode 5 of Machine Learning with R, a really fantastic journey. I'm Hamid Reza Hassani, PhD of Computer Engineering, researcher, data scientist, and founder of DataBiox. I'm really happy to see you again in this episode. So you remember in the previous episodes we already started with from first episode we started from regression, then go to clustering and have lots of discussion on clustering. Remember in the previous episodes we covered k-means in two algorithm PAM, partition around medoids, and also PAM-K, and we already discussed k-means and k-medoids. In this episode we wanna discuss and cover another type of clustering algorithm, which is DBSCAN. So the concept and the lesson of this episode is DBSCAN algorithm. Yeah. Okay, so let's see what is this DBSCAN according to this copilot. I love the copilot. It's really nice, and so let's see. And also this Edge Explorer is becoming popular for me because of its handy, for example, for making notes. DBSCAN, density-based spatial clustering of applications with noise, is a powerful clustering algorithm used in machine learning. So let's see what are the, and again we want to apply it on our famous flowers dataset. That in all of these previous 4 episodes we already worked on this with different algorithms. So let's like all previous episodes have some concepts and fundamental and theoretical review, this time from a lecture from Dr. Jing Gao from Buffalo University, named clustering density-based methods. So let's see and review the basic ideas. Clusters are dense region. So here the emphasis and the important thing is as the name tells to us, DBSCAN, density based. So density is important for us for making and for making the clusters and defining them. So clusters are dense regions in the data space. Here a space, we know that it is density based spatial, so it's related to a space, separated by regions of lower object density. A cluster is defined as a maximal set of density connected points, and this covers clusters of arbitrary shape. You see that the shapes of clusters are different, and they are not a unique shape. So the method name is DBSCAN. So these are some definitions. As like previous episodes, I will share all of these documents, and these all are also available on the web, and I'll also share the links with you. So we have two important definition here in DBSCAN. First of all, epsilon, or this one, objects within a radius of epsilon from an object. So if P is an object, so this epsilon is radius. So objects within a radius of epsilon from an object are epsilon neighborhood. So high density, another definition, high density epsilon neighborhood of an object contains at least minPts. This is another important definition, minPts of objects. So in the neighborhood, in the epsilon neighborhood, in the radius of epsilon from a point the objects in this area are minPts. Okay, so let's see what it tells to us. Here we see that density of P is high for minPts, mean points, to 4. We see that, yeah, the density, because here we see that in this epsilon radius there are 4 points, so the density is high. But density of Q is low for mean points to set to 4. You see, it's clear. And also, for better understanding of these two parameters, epsilon and mean points, you can refer to this paper, fast DBSCAN, fast density based clustering with R, that you can find it on the web from these others, from different universities. You see that it has defined in another way. You can see we will cover this, don't worry, we will cover this border, core and noise in the later slides, but here I wanna just show you the definition of epsilon neighborhood and point classes. This is epsilon neighborhood, another definition. Yeah, the epsilon neighborhood, yes, sorry, let's make it, yes, the epsilon neighborhood, and epsilon of point P of a data point P is a set of points within a specified radius epsilon around P. Okay. And we already know the mean points, yeah, and the threshold. Here we can also read this following this definition. The size of the neighborhood can be seen as a simple unnormalized kernel density estimate around P using a uniform kernel and a bandwidth of epsilon. DBSCAN use n epsilon P and the threshold called mean points or minPts to detect dense regions. So minPts is used to detect dense regions and to classify the points in a dataset into core, border, and noise points. So this is very important to know that one of the applications of minPts is to find core, border, and noise points. So what are these points? We see that we have some core points here. Core points. A core point, so here we have already given epsilon and mean points categorized objects into 3 exclusive groups. A point is a core point if it has more than a specified number of points, if it has more than a specified number of points, mean points, within the epsilon radius. Yes, these are points that are at the interior of a cluster. So we see that in this epsilon radius it has more than here we had set this mean points to 5, so here 1 2 3 4 5 6, so it is a core points, yeah, because we have 6 points in the neighborhood of this point P, so this is a core point. So you see that 6 is more than 5. Yes. So a border point like this has a fewer than mean points within epsilon radius. So this is very important. And also for border point has fewer than mean points within EPS radius, but is in the neighborhood of a core point. And finally, the noise point. A noise point is any point that is not a core point nor a border point. I think this is a good and clear definition. For more and another definition, you can also refer to this more mathematically organized. So these are the definitions, and here you see the example. If we suppose that the blue, this one, is original points, here is the result. So we see that the result based on DBSCAN, the point cores are green ones and the borders are blue, like these ones you see, and the red ones are outliers. It's really nice. Yeah. For many things, when we see, we can apply these algorithms in the practice. For example, in the molecules. For those who are interested in biology, molecular pathology, and many things, it's applicable and very nice for, especially for molecular pathology. You can classify the subtypes, and it's really fantastic, and I love this concept. So this is another thing, density reachability. Yeah, and these are some other definitions that for hands-on experience, because our purpose is to get hands-on, to have hands-on experience with R. So you can review these definitions by yourself, and it's easy to find out. Okay, I think these are after these discussions and the explanation, is very easy for you to find it. And if you have any question, you can ask me or share in the comments. But another important thing is that DBSCAN algorithm mechanism is sensitive to parameters. It's very important. So it's very important how you set the parameters. So here you see, for example, in A, the EPS, the mean points at both are set at 4, but EPS at this one is set to 0.5, but here is here epsilon is set to 0.5, but here 0.4, and you see very different from each other. Yes, sorry, let me yeah, you see this. So this picture is very nice, and remembers me again the molecular subtypes in pathology. It's really nice. Maybe in the future we can also check some problems in this. It's really nice. So you see that it's very sensitive to the parameters, and it's important how we set. And what is the problem? First of all, we should understand what is the problem and then set the appropriate parameters. Here also we see that the result of DBSCAN with minimum points at 4 and EPS at here is 5. Here the EPS is 5, here is EPS 3.5, and here 3. You see that yeah, when you make it less, you see that here we have yeah, it's totally different from this, because here the radius is larger, but here the radius is less. So you can see the colors are more, and there are some more clusters, and it's really it gives us a very good insight, and it's very interesting. So yeah, and there are some methods for determining the EPS and mean points that in practice we will also cover it later. So first of all, let's do some hands-on experience. Yes, Okay, yeah, we see that. Also, another important and one of the another positive point of this DBSCAN is that it's resistant to noise. Remember, some of the previous discussed algorithms was not resistant to noise, so it is very good and can handle clusters of different shapes and size. That's really important. So yeah, and in some cases also DBS can not work well. You already know that it's sensitive to parameters. It's very important how to set the parameters by experiment, and how hard to determine the correct set of parameters. It's one of its points, maybe weakness point, and cannot handle varying densities. Yeah. Okay, so let's go to hands-on experience. Again, these nice slides from data clustering with R from Yanchang Zhou. And let's go to page 38, density-based clustering, and let's do the hands-on experience with codes in R. So you already know this and these introduction and review and background of this clustering algorithm, so no need to review again. Yeah, just this DBSCAN is a typical density-based clustering algorithm which works by expanding cluster to their dense this is very important, which works by expanding the cluster to their dense neighborhoods, by Esther et al. In 1996. And another things we see here, other density-based clustering techniques. We have optics and also then you see this by these scientists. Yeah. Okay, we already also discussed this point. The advantage of the density-based clustering is that it can filter out noise and find clusters of arbitrary shapes. Yeah, we already covered it. These are also some other points that we already discussed. And please remember that in R, we should again import FPC library. FPC library. That in the previous episode we already introduced it and have used it. So remember. These are also again repeat these concepts: EPS, reachability distance, another definition here which defines the size of neighborhood or radius and minimum number of points within this radius. Yeah, so okay, here are also another definitions of dense point and density reachable. Let's just also review this and then go to the codes. If the number of points in the neighborhood of point alpha is not less than minimum points, then alpha is a dense point. We already have discussed with another definition. For example, core, you remember, the numbers are more than minimum points. This is another definition. And all points in its neighborhood are density reachable from alpha are put into the same cluster as alpha. Okay, so first of all, you remember we should import library and define library FPC. Let's yeah, you remember this, it was for PAM, and in the previous episode we had PAMK, a nice clustering algorithm. But now let's define library FPC. Yes, control enter, and then here you remember another nice representation for removing the class tags. You remember another way for this, we have this code iris2 iris species. we make this null. Yes, you remember this from before. So here is another way for removing the class tags. You remember that iris data and the famous dataset flowers. Here is the fifth 1 2 3 4 5. The fifth column is a species that here we don't wanna. So you remember one of the way that we already discussed was this iris2 iris species. You remember that we make it null. Yes, and yeah, I can show you here. Yes, you remember? Yeah, this one. So yeah, I should, yeah, here is the right one. Sorry, here is the right one. Iris2 species to null. Yeah. Yes, first of all we copy iris on iris2 and then this one. Okay. Here it is another way of making this. Write this command. Iris2 is iris and removing the last or the fifth column, which is here the last column. So let's see, check that is it removed or not. Yeah, we see that the last column, the fifth column, is removed. So another thing here is to run DBSCAN on iris2. Here we have set the EPS to 0.42. Here as a practice you can check another parameters here. You remember that setting the parameters are really important here, and it's very sensitive, and you remember it was one of the weakness of this algorithm, and minimum points set to 5. These are set by the author of this presentation, and based on the practice you can, and we will also practice another parameters in the next episode. But here let's try this DBSCAN on iris2 epsilon equal to 0.42, and let's see, and put the result in DS. So DBSCAN, the data on iris2, and EPS equal to the radius value for 0.42, and again here the minimum points to 5. Yes, minimum points to 5. Yeah, then let's see the DS. We have the border, and the border, yeah, we have the seed as core and total. You see, yeah, and these are these three categories. This 0, you will see that this is the outliers. So you see the result, and this is density based clustering of, yeah, again with this nice table we compare the clusters of the real species, the real clusters of iris with these clusters made by DBSCAN. So let's see and let's compare. First of all, it's it's cluster and iris species. Yeah, so you see what are the explanation here. You see from 1 to 3 is identified clusters, 0 noises or outliers for each of them. For example, for Setosa You remember, just for, yes, this, it was Setosa, versicolor, and virginica, the three types of iris flowers, nice iris flowers. So you see, yeah, the outliers for Setosa is less than versicolor and virginica. You see that for Setosa is like other previous discussed algorithms, it clearly separate. And here we see 37 for versicolor and 33 for virginica. We see that for virginica we have some more outliers here. For this less, and the very less than others. Yes. Okay, so here we see we want to plot the result of this DBSCAN on this data set. Let's see. Plot DS and iris 2. Yeah, you see, and you can zoom it and check the result. Yes, sepal length, sepal width. Yeah, very nice. Based on sepal length, you see sepal width, petal length, and petal width. Very nice. Okay, and another thing we wanna check is, for example, we want just to see the first column and fourth column. This means for all rows, but just selecting the first and fourth column. Just first and fourth column. Okay, so let's see. You remember the first and fourth color was what? Yeah, so when we say, yeah, what it means, yes. So we see, yeah, sepal length and petal width. So we want to plot DS and based on this, yeah, yeah. So we see based on petal width and sepal length. Yeah, it's very nice clustering based on these two items. Okay, and here another thing, it's really interesting. Plot cluster for iris 2 based on the cluster. Let's see. Plot cluster for iris 2 and DS. Yes, we see this. Yeah. You see the zeros, the ones are here very well separated from others. You see some outliers here, yes, and these 2 and 3s, and you remember some outliers here. It really nicely shows to us this, yeah, this one. Yes, very nice. So plot clusters, it was another thing that we have learned in this episode. So yeah, the concept for the next session is prediction with clustering model and some interesting and fantastic things with this DBSCAN cluster, and we will also change these parameters and check what would be the results. So it would so as I told in the first moments of each episode, that is really fantastic. So you see that it's really fantastic, and all of us are curious. Really, I'm curious about the and very passionate about the next things that will gonna happen, and I will try my best to produce contents as much as possible, and we will continue and keep on this way until deep learning and many other concepts that may be helpful and joyful for you. I hope that you enjoyed this episode, and thanks for watching, and hope to see you in the next episode. Bye.